Hello everyone. So in this video we'll be talking about the confidence interval of sigma square. Confidence interval of sigma square. So in the previous few videos we have been talking about your confidence interval in the case of your interval estimation. Okay. So we have discussed the confidence interval creation for your estimators or your regression coefficient, that is beta 1 and beta 2. So in here we'll be talking about your confidence interval for the variance of the estimator, right? So one thing that you have to take as given here, so I won't be explaining this thing because that will be a part of some other discussion that will be in statistics videos. Okay, so we've been following the normality assumption majorly throughout the videos. Okay, right? In the case of C, classical linear normal regression model. Okay, a classical normal linear regression model, CNLRM. Okay, so this normality assumption has always been there. So under this assumption, the variable chi square, we call this the chi square variable. Okay, or say variable chi square, which is defined by n minus 2, which is the degree of freedom, and sigma hat square upon sigma square. This variable follows a chi-square distribution. So this is given, or you should remember this. Okay. So if I have to create an interval around this, so chi-square is basically uh, the squared distribution of a random distribution. In a very simple term, if I have to explain a bit about it. So a chi-square distribution always has positive values in it. Okay, so there can't be any negative values because it is a square of a already existing distribution. Okay, so the confidence interval would look like this: chi square 1 minus alpha by 2. So it can't be alpha by 2 because there can't be any negative values. Okay, and chi square chi square alpha by 2 is equal to 1 minus alpha. So this is the confidence interval and this is the probability of my chi-square variable or chi-square statistic lying in this interval. Okay, if I have to show this graphically, so let me change the color. So it will look like, so it looks like a normal distribution only. Okay, so this is your, so for, so this graph is being created for the values wherein 95% is the confidence interval, or alpha is equal, or significance level is 5%, and the degrees of freedom is 11. So in this case, the values will be something like this. So this value will be, this critical value will be 3.8157, and in here the value, so this is this value, and this value will be 21.9200. Okay, so this portion is 2.5% of the area, and this portion is 2.5% of the area. So the probability of my true population parameter, that is in this case as the variance, sample variance or the population variance, is lying in this range is 95%. Okay, according to this setup. Okay, right? So if I rearrange this entire thing just like the way I had done for the t value, so something of this sort will be coming up. So probability n minus 2 sigma hat square upon chi square alpha by 2 sigma square n minus 2 sigma hat square upon chi square 1 minus alpha by 2. This entire thing has a 1 minus alpha probability. So this value lying in this range, okay, has this probability of 1 minus alpha. So this is, so in the case of variance or population variance, we use the chi-square statistic. Just remember this because it involves squaring of a distribution, and because in the case of your variance we have to square the values, right? Remember, try to remember this thing. So that is why the chi-square distribution is relevant here. So just try to read about chi-square distribution and you'll find that how it is necessary to use it in here. Okay, how it is very helpful. So this was about the sample variance, sorry, the population variance and the confidence interval for it. Okay, so in the next video, with all this knowledge of interval estimation and confidence interval of the different statistics and estimators, okay, so with the help of these we'll be talking about hypothesis testing in the next video. So it is a very important topic, and I hope you'll enjoy it because it is very interesting also. So I'll see you in the next video. Till then, take care.